Hi, I am Vector. Have you ever wondered this? How would you make a computer turn speech into text, recognize handwritten digits, or predict tomorrow's weather or stock prices? The underlying function that maps input to output is far too complex to write down ourselves, but we know such a function does exist. So instead of finding the exact function, what if we just approximate it as closely as possible? The universal approximation theorem tells us that any continuous function can be approximated, given enough neurons. A neuron is the basic unit of neural networks. It performs a weighted sum of its inputs, adds a bias, and applies an activation function. That activation function introduces nonlinearity, allowing the network to learn patterns that aren't simple or linear. By using many neurons, we can model a wide range of complex relationships between inputs and outputs. We can also organize these neurons into layers, with each layer building on top of what the previous layer learned. The input flows through the network, producing an output. Our goal is for this output to be as close as possible to the actual answer. So how do we get there? By adjusting the weights and biases of the neurons to minimize the difference or error between predicted and true values. In the next video, we'll see why finding the best combination of weights and biases is a monumentally difficult task, and how math gives us a shortcut to get close to the optimal values.